Hi guys, Audrey here. So we've been working on differential equations. Hopefully you guys are comfortable solving them by now. I thought today we would do an example of a differential equation word problem to see how differential equations can be applied to real world situations, how they can be useful for solving them. So let's read the question. Let us assume that in Italy, the number of people with COVID-19 has been growing at a rate that is proportional to the number of people infected. So first of all, it's important to note that this is a little bit of a simplifying assumption. When you get further into this subject, so for example, if you take a differential equations class, you'll start learning how to make more complicated assumptions. It's simplifying, but it's still a good basic idea of what's actually going on. So it's been growing at a rate that is proportional to the number of people infected. On January 31st, 2020, there were 2 known cases of the coronavirus in Italy. By February 28th, 2020, there were 888 people infected. So first, we want to find an equation that represents the number of people infected at a given time. And second, we want to use this equation to find out how many people would we expect to be infected on March 16th. Okay, so we're going to start off by trying to interpret all of the information from this question. First of all, we want to know an equation that represents the number of people infected at a given time. So we're going to define a new variable that we will call n of t, and we're going to let that n represent the number of people infected at a given time. Now, note that the number of people infected is constantly changing as time changes, so we can think of this n as a function of t. That's why we've written it that way. We're also going to be measuring t in days. Next, what we want is something that, an equation that represents this, but what we're given is a growth rate. So we're going to define d in dt. When we think about it, what d in dt means is change in n, so change in number of people infected, over change in time. So this is telling me how fast the number of people infected is changing over time. So we can actually, in this particular question, use the very first sentence to come up with a word problem, come up with a differential equation that represents what's going on in this word problem. So what it says is that it has the number of people with COVID-19, number of people with COVID-19 has been growing. That right there is my d in dt. So d in dt at a rate that is proportional. Now, what does proportional mean? So let's think about this in simpler terms. If I say that how much I am paid is proportional to the number of hours I work, well, that would mean that I'm paid at an hourly rate. So let's say that I'm paid $20 an hour. At 1 hour, I get $20. At 2, I get 40. At 3, I get 60. So the number of hours multiplied by 20 is proportional to the number of hours I work, how much I'm getting paid. That 20 being the proportion. Each time I'm multiplying the new time by 20. So proportional, it really just means multiplied by some constant. So we can actually just stick a constant right there. Now what's it proportional to? So it's proportional, that was my k, to the number of people infected. Well, guess what? We already defined that, that's n. This is our differential equation. Now that k in it is just some constant, it's unknown. So we're gonna need to solve for it. We're also gonna end up with a plus c when we solve this differential equation. So we have 2 constants we need to solve for, which means we need 2 initial conditions, and we have them. So let's get them out of the question. The first initial condition says that January 31st, there were 2 cases. So my initial conditions The first one is January 31st. we're going to call this t equals 0 because this is before time has started changing. This is when like, oh, wait, hey, look, this thing's happened. So time hasn't started changing yet. We'll call it t equals 0, and n was equal to 2. Then on February 28th, there were 880 cases. So that's my second initial condition. Well, February 28th, that's after 28 days have passed, which means n is equal to 888 when t is equal to 28. Okay, so now we actually have all of the information that we need to solve this differential equation. So let's do it. Oops. So we have that dn dt is equal to kn. I'm going to start off by multiplying the t over to the right side and dividing the n over to the other side. We get 1 over n dn is equal to k dt. Remember, as much as possible, we want to try to keep the constants over there on the t side. It's going to help make things a little bit simpler later. All right, so now we integrate both sides. Integral, integral, to get natural log of the absolute value of n is equal to kt plus a constant. And we know to solve for n, we'll have e to the power of both sides. Give me the absolute value of n is equal to e to the kt plus c. Now, we did divide by n in the beginning there. Going to be 0. We hope that it's going to be. It is that it's growing and it's getting bigger and bigger, and we're starting at this place where n is equal to 2. So already we don't have the 0 case thing going on. So we don't really have to worry about that. That said, it will be easier to still deal with constants in the same way that we have in the past. So I'm going to then conclude that n is equal to big C e to the kt. Now, again, the main reason we did that here was to make this easier to solve for c, but also to get rid of that absolute value. I'm going to do another thing to make solving for the constants easier. We're going to think of this as n of t is equal to c times e to the k to the power of t. K is an unknown. It's a thing I'm trying to solve for, but e to the k is also just a constant. K was a constant, e to the k is a constant. It will be easier to solve for e to the k than to solve for k. So that's what we're going to do. So now we want to go from here and plug in our initial conditions. T equals 0, n is equal to 2. So we will have 2 is equal to c e to the k to the 0. So 2 is equal to c. Look at that. Giving me n of t is equal to 2 e to the k to the t. Now we have t is equal to 28. N is equal to 888. So we get 888 is equal to 2 e to the k to the power of 28, which means e to the k to the power of 28 is equal to 444. Now, remember, we're just solving for e to the k. It's easier to solve for than solving for k. To isolate e to the k here, I just need to take this equation and put both sides to the power of 1 over 28. So that my e to the k is equal to 444 to the power of 1 over 28. All right. So now we can say then that n of t is equal to 2 times 444 to the 1 over 28 to the power of t. But when we have an exponent to an exponent, we can multiply those things together. So we get 2, 444 to the t over 28 is my n of t. And that right there represents the number of people infected at any given time. Now, if we were to graph this thing, you'll notice that it's actually an exponential function. We have e to some power. So in our final answer, it looks a little bit different. It's 444 to the power of t. So this is actually representing exponential growth. We have an exponential function here. If we graph this thing, it started at 2, and then it just gets big really fast. So in other words, when something is proportional to the value, so we had it's proportional to the number of people, this ended with exponential growth. So that said, the next question was, what's happening on March 16th? How many people would we expect to be infected on March 16th? So what is March 16th? What t-value does that represent? Well, March 16th, we know that February 1st was day 1, January 31st was day 0. There were 29 days this February. Hang on, I want that to be blue. There were 29 days this February. So plus 16 equals to 45. So March 16th is day 45. So we just have to plug that in to the equation that we got there. Now, clearly, you cannot do that without a calculator. 444 to the power of 45 over 28. You probably need a calculator for that. That's okay. Typically, you could just leave your answer like this, but for the context of this question, it's going to be better to know exactly what that means. So we'll plug it into a calculator, and when we do, we get 35,954. So we would expect 35,954 people to be infected on March 16th. And that is our final answer for the second part. Now, the thing is, March 16th is over. It's already passed. And we know that there were actually only 27,980 people, according to Wikipedia, infected on March 16th. So we started off with that simplifying assumption. We knew that we were going to be off a little bit because this wasn't exact, but we're actually pretty close given the circumstances. Anyway, that's all. Bye, guys.